Hey guys, I am ready for our next unit, and I hope you guys are too with what we are going to be doing. So, in this unit, we are going to be focusing in on functions. So, I know when we did equations, I had written chapter, book has changed, all of this kind of stuff. So, we're going to start calling them units and modules. I know it's going to sound really weird, but we're going to go with that. All right, so this is where you kind of do that divider page. It's going to say Unit 2 functions. So because you skipped 8th grade math, we have to talk about what functions actually are. So this module, this unit is going to be newer to you, but understand you've been doing this topic all along. All right, so we are going to start off in our realm of graphing relationships. So you can either be following along with me on your printed out notes or you can be writing them as well. These are story based, so you will be writing all of the details to it, so understand that about it. All right, so the first thing that we need to understand is that when things get graphed, we're illustrating facts to follow a rule. We're following a story. We're following this procedure that's happening with our numbers and with our symbols. So we need to make sure we're utilizing these key words from our stories to make sure we can actually graph it appropriately. All right, so we're going to take a look at this first example of relating graphs to particular situations. All right, I love this part because math is about storytelling and it's about making sure you know what's happening and what we're doing with it. All right, so here is our story. Again, I know it's a lot of words, but it is what it is. So it says the air temperature was constant for several hours at the beginning of the day. So temperature. Okay, so you woke up, it stayed constant most of the morning. It said then it rose steadily for several hours. It stayed that same temperature for most of the day before dropping sharply at sundown. Now, you've all experienced that. You're in your shorts and t-shirts, the sun is out, and then suddenly the sun goes away and you realize you're freezing. So again, the temperature was constant for several hours at the beginning of the day. It rose steadily for several hours. It stayed that same temperature for most of the day before dropping sharply at sundown. All right, so that's the story we have. So we're going to graph this. Notice my story doesn't have any numbers. Weird, right? All right, so we have to deal with, well, what is the labels of the axes? What is it that I'm working through? So you'll notice that I am dealing with temperature as time passes. So the graph that we're going to be working through is as time goes on, how does the temperature change, right? So I have here three different graphs. We have graph A, graph B, and graph C. Okay, again, notice that there are no numbers. All right, our x-axis is as time passes, so as my time moves on. And my y-axis is how does the temperature change. So I want you to take a moment, I want you to look at these three graphs. Which graph would you say tells this story? It was constant for several hours at the beginning. It rose steadily for several hours. It stayed the same temperature for most of the day before dropping sharply at sundown. Right, so graph A, graph B, or graph C, which graph would you say tells this story? Now, hopefully, you paid attention to these key words of our story. We have the word constant, rose steadily, stayed the same, and dropped sharply. That was each of our sentences. So the temperature was constant. How do you think constant would look? So the word constant means that my line is probably going to be going flat across. It is consistently that temperature. Rising steadily is going to be an incline. However, is it really, really steep? Probably not. It's going to probably be more of a diagonal of it steadily rising. If something's staying the same, chances are it's going to be another flat line. And if we're dropping sharply, well, we're going to have a line that declines, but it's going to be at a quicker pace. So these 4 words tell the 4 different segments in my graph. So if I started constant for several hours, well, I can't be C because C was rising right away. So C can't be my answer. Okay, so we have in A, we kind of have that constant. And B, we still have a constant too, so maybe it's between A and B. So now from that constant, we have to raise steadily for several hours. So A, we're raising steadily. For B, we're raising steadily. So those ones are about the same, still A and B. So now it stayed the same for most of the day. So notice at the top here versus the top here. So who would be staying the same? In this case, B would be our winner. And now we have to check our last one. Dropping sharply, it's in fact B. All right, so hopefully you can visually see how this story plays out in graph mode. Okay. Now with our graphs, there are actually 2 different types of graphs. All right, when we connect the points, we call those continuous graphs. It means that there's data in between it. So as time was going on, we have seconds, we have minutes, we have hours, we have little gaps of time. That means we have a connected line. We also have some graphs that are called discrete graphs. And discrete graphs are when we're dealing with data that are whole numbers. There's no information between the numbers. All right? So for example, if we had a graph of the theme park attendance, that would be considered discrete because it's the number of people in whole numbers only. It would be a series of dots on the graph. All right, so if we were taking at 1 o'clock, how many people were in Cedar Point? You're not going to have, 1,100.53. You can't have 0.53 of a person. But that data does not connect to 2 o'clock. Okay? All right, so let's take a look at this story. So we're going to practice again sketching a graph. Okay? So it says Simon is selling candles to raise money. Each he sells, the school will get $2.50, and he has 10 candles to sell. So he was given 10 candles. They're $2.50 each. We got to graph this. Okay? So we have our own little graph here of what we're going to do. I'm going to uncover that here in just a second. All right, I did put numbers to it because we are dealing with numbers in our story. And we have to graph this. So this bottom would be the number of candles. And the y-axis would then be money earned. Now notice I'm counting by fives, and this is 50 cents. Okay, so understand that maybe I don't want to graph 1 candle to begin with because I'm dealing with halves data. I can go to 2 knowing that it's going to be a whole number. So if I sell 2 candles, how much money am I going to make? $5. If I sell 4 candles, I'm going to have $10. 6 candles. How much for 6 candles? Oh, 15. And if you're not sure what we're doing, we're just taking 6 times 250. Okay. Now I can fill in my in-betweenies. So again, I get $15 for 6. I get $20 for 8. And I get $25 for 10. And then I can fill in the in-betweenies here as well because it should make a straight line because it's $2.50 increments. The question is, do I connect these points? If I were to connect these points, you're telling me that I'm selling 1.5 candles. So you take a candle home, you burn half of it, and you're like, hey, anybody want this half candle? No, unfortunately, that's not how it works. You're selling full candles. So I do not connect these dots. So then the question is, because I'm not connecting these dots, is this considered continuous or is this considered discrete? And it would be considered a discrete graph because I'm not connecting the dots. Okay. So what questions do you have? Anything that deals with continuous or discrete? Now, if you did have any questions, I will make sure I go through them and I'm able to answer them for you. All right, so here is another story. All right, here I do not have numbers, so I'm not going to put any numbers on my graph. Okay, but you're going to read this story, and I want you to try and graph this. Okay, so I'm going to tell the story. I'm going to read it out loud, and I want you to graph it as I'm telling the story to you to see if you can kind of alter high, low, and all of that. Okay, so it says, Angie's heart rate is being monitored. Okay. While walking, her heart rate remains the same. As she increases her pace, it rises steadily. And when she runs, it increases more rapidly and then remains high. As her pace slows, her heart rate slows and returns to normal. So go ahead and graph that picture. Okay, let's see if your graph matches my graph. All right, and I'm going to use different color pens because every time I change directions, it should illustrate from my story. All right, so I'm going to grab some different colors so you can kind of see the breakdown of where things move and scoop. All right, so we start off walking. Okay, so I'm going to start off here. I can't start at 0 because my heart's moving. So this is time, and this is my heart rate. So if I have 0 heart rate, it means I'm not alive, and I am breathing because I'm walking. Okay, so my heart rate while walking remains the same. Okay, so this is my heart rate remaining the same. Okay, I'm now going to increase my pace, which means it's going to rise steadily. So from here, we're going to do some rising. Ooh, then I start to run. So it increases more rapidly. So this increase suddenly shoots up. So notice I have 2 different segments, one going steadily up and then one increasing. It then remains high, which means I should then plateau this off at this height of my heart rate being up. Okay. As my pace slows, my heart rate slows. And then it says it returns to normal. So I'm going to actually bring this line down below my walking weight, my walking rate. Is this what yours looks like? Do you have it flat, then semi up, and then shooting up, and then staying the same, and then gradually coming down, and then being lower because now I'm not moving anymore? Think about running a treadmill. All right, you set the time, you walk, your heart rate gets up, you speed it up really fast, and now you're running. You don't just jump off of the treadmill. You start to slow it down until gradually your heart rate becomes normal and you can get off and do something else. All right, so how'd you do on this? Did you match me exactly? All right, so now for our last component, sketching or writing your own story to the sketch. So it says, when sketching or interpreting a graph, pay close attention to the labels. So here we are writing the situation. All right, so let's take a look at this. As time passes, this is my water level. So my water level goes up, stays here, comes down. But notice it's all the way at 0s when it starts and ends. Write me a story. Should have 3 sentences, 1 sentence for this up, 1 sentence for this across, and 1 sentence for this down. I'm excited to read what you write. All right, so here is a couple of stories that I might say. As a mom, this happens to me often. I fill a cup with water. That cup sits on my counter because I got distracted doing something else. And then either it gets knocked over by a ball and spilled, or I'm so thirsty that I just drink it all up. Okay. Another story some people might say is that I'm filling up a bucket of water to play outside. The bucket sits outside because I forget about it, or I was waiting for somebody to come outside to play with me. And then the bucket spills over and dumps out. A lot of people like to use the bathtub example. The only catch is that means I'm filling up the bathtub and never getting in it. Because think about science and water displacement. If I got in the tub, wouldn't there be a slight increase? And then when I got out of the tub, a slight decrease before the water drained? Unless you're already sitting in the tub. Because if you're sitting in the tub with no water, the water would fill. You take your bath, hoping you don't splash out of the pool, and then the water decreases. All right? So I hope this helps you get an understand of how things relate together. Because from this, then, we're going to take a focus a little bit in more detail of actually what functions are and the relations that tie with them.